What is the pathogenesis of chronic fatigue syndrome? Imagine feeling exhausted all the time, no matter how much rest you get, and experiencing other puzzling symptoms like brain fog, muscle pain, or dizziness. Chronic fatigue syndrome, also called myalgic encephalomyelitis, is a complex condition that scientists are still working to fully understand. Its causes involve many systems in the body working together in ways that are not yet completely clear. One key part of the puzzle is the immune system. In people with this condition, the immune response seems to be out of balance. Some immune cells, like natural killer cells, do not work as they should. There are also changes in T cell responses, and the body produces more pro-inflammatory substances called cytokines. This ongoing low-level inflammation might make people feel malaise or flu-like symptoms. Some researchers believe that the immune system might mistakenly attack the body's own tissues, which is called autoimmunity. Evidence suggests that autoantibodies, proteins that target the body's own receptors, could interfere with how blood vessels and nerves work, possibly leading to symptoms like dizziness when standing up or difficulty regulating blood flow. Another important factor involves the nervous system. Neuroinflammation, or inflammation in the brain and nerves, seems to play a role. Brain scans have shown abnormalities in areas like the brainstem, which helps control vital functions. There is also evidence of altered brain metabolism and problems with the autonomic nervous system, which controls things like heart rate and blood pressure. These neurological changes can explain some of the cognitive issues and the difficulty in maintaining stable autonomic functions. Energy production at the cellular level is also affected. Mitochondria, the tiny power plants inside cells, do not produce energy efficiently in people with ME/CFS. This mitochondrial dysfunction results in less available energy, making even simple activities exhausting. Researchers have observed that key regulators of energy metabolism, such as AMP-activated protein kinase and the target of rapamycin complex 1, are disrupted. This leads to a buildup of oxidative stress, where harmful reactive oxygen species damage cells and mitochondria, further impairing energy production. This energy crisis explains why patients often experience post-exertional malaise, where symptoms worsen after physical or mental activity. Systemic inflammation and blood vessel issues also contribute. Inflammation can damage the lining of blood vessels, causing endothelial dysfunction. This can lead to abnormal blood clotting, constricted blood vessels, and reduced oxygen delivery to tissues. Such vascular problems can worsen fatigue and other symptoms by limiting the supply of oxygen and nutrients to muscles and organs. Environmental factors and genetics are also involved. Many cases of ME/CFS start after infections or stressful events, suggesting that external triggers may set off the disease in people who are genetically predisposed. The condition appears to result from a complex interaction between genes and environmental stressors, which together disrupt immune responses, metabolism, and nervous system function. In summary, the development of chronic fatigue syndrome involves a web of interconnected issues. Immune dysregulation, neuroinflammation, mitochondrial energy problems, and vascular abnormalities all play a part. These factors combine to produce the persistent fatigue, cognitive difficulties, and autonomic symptoms that define the condition. Ongoing research aims to identify specific biomarkers to help diagnose and treat this challenging disorder more effectively. If you or someone you know is experiencing symptoms like these, it is important to consult a healthcare professional for personalized evaluation and care.